Hi everyone, you are welcome to my YouTube channel. I am Ridwan Ibrahim, and in this video I'll be making a review on ProtaStructure, whether it overdesigns, underdesigns, or it accurately designs a RC column. Then how am I going to confirm that? What I will do is, since the model is here, I will just run the analysis, run the design, and then I can check the area of steel required. Then I will compare that with what is on the steel table. Then I'm going to confirm if the area of steel supplied or area of steel provided is actually in excess or if it is accurate. So let's do that. I will go to analysis. The building analysis has been run because in the last video we ran the analysis for this same building, so I'm not going to cancel the building analysis. I'll just go to building analysis, and then I will go to edit material. Why I'm doing this is I want to pick a single diameter for the column. So I'll go to concrete column, then the rebar diameter. I'll make sure I select Y16 alone. Y16 alone. Yours can be Y20 alone, but I'll just select Y6. I do not want to mix it. So click on OK, and then OK, and then I can just close this. Alright, the building analysis is still there. Changing that will not affect your building analysis. I can just go to design, and then I will go to column design, and now I will just go to column batch design, and then I'll just reselect my bars since I've made a change to the bar. So I have to click on reselect all bars, and then I can calculate. Alright, that is done. Then just click on close. Now you see that everything has been redesigned, and then they are all successful. You can see them in green color, so that is good. Now this particular one, this is 1C1, that is the column 1 in story 1. Okay, this is 2C1, that is the column 1 in story 2. So before I go further, you will see that this particular one, 1C1, is supposed to be at the lower bottom because it is in story 1. Why this is in story 2? But if you check the rebar that is being supplied, you will see that the one which is in story 2 has more rebar compared to the one in story 1. You can see this one is just 4Y16, while this one is 8Y16. This is 8Y16. So the column at the top is even having 8Y16, while the one at the bottom is having 4Y16. That shouldn't be possible, because the column at the lower story should be carrying more load compared to the one at the top. So definitely the number of bars that will be supplied to the ones at the bottom should be higher than the one at the top. So there is something wrong with this. Okay, however, let's just go into it so that we can see what is required and what has been supplied. So I'll double click on this first one. Now you can see the number of steel provided is 4Y16. When you check this diagram, you will see just that. You can see this is 4 numbers. Now let's see, when you check here, you will see this is what you required. This is AS required. The AS required is 604.88 millimeters squared, and this is the AS that has been supplied. You have 804.25. Of course, you should know that what you supply should be higher than what is required. If what is required is 604, then you should provide what is required. But if you cannot provide exactly what is required, what you should supply shouldn't be less than what is required. It should be more than what is required. Okay, but it should not excessively be more. Okay, so that is the point. Now let's see. Of course, this is a column of 230 by 230. You can check that here. You will see it is a 230 by 230 column. So that is a square column. And from the last video, I told you that whenever you have a square column or a square beam or any elements that has a square shape or a rectangular shape, the minimum number of bars that can be provided is 4. Alright, so now we check the steel table. The required AS is 604. Now let's see what we have. So we are using 16 mm, so I'll just check 16 mm, and then you can see this one is 201. Definitely this is less. This is 402. No, this is 603. However, what we have as the minimum is 604, not even 603. So 604 is higher than 603. That means I cannot take this. Then I have to take the next one, which is 804. 804. And 804 will give me how many numbers? It will give me 4 numbers. Of course, even if 603 passes, I cannot use 603 as my area of steel provided, because 603 will give me just 3 numbers, and I cannot use 3 numbers for a square section. If it is a triangular section, I can use 3 numbers, but since it is a square section, I will have to use at least 4 numbers. So it has to provide 804, and that is exactly what it has provided. So you see, this is exactly what it has provided. It has provided 804.25, which is 804, approximately 804. So this is okay. It is not an over design. It is, it is something that is reasonable. Okay, so let's just close this and go to another column. Now let's see this column that has been provided with 8y16. 8y16 is a very high number of steel for a 230 by 230 column. Let's open that. Now if you see, the column is still 230 by 230 and the cover is 25 mm. Now you can see the number of bar that has been provided is what? 8y16. 8 numbers. You can see 3 at the top, 3 at the bottom, and 2 at the center. So that is 8y16. The area of steel required is 1017 mm squared, and what has been supplied, what has been provided is 1608. Now let's see, the required is 1017. We are going to need the required. Okay, now 1017, let's check that. Now y16, this is y16 that we are going to check. It can't be this, it can't be this, it can't be this. 1010. Now let's see this. This 1210 is greater than 1017, and what is the number? 6 numbers. You can see, so it tells you that 6 numbers can actually work. Area of steel of 1210, it is better compared to using 1610. 1610 will give you 8 numbers, whereas 1210 will give you 6 numbers, and that is even more reasonable. Okay, so I can use this. So let's change that. I will just take away this. Okay, then I can have 3 at the top, 3 at the bottom. Now if you check your area of steel now, you will see that this is now 1206. So this, the supplied is still more than the required. Okay, so this is even more better than what was provided before, which is 1600 and something. Okay, but what the software is trying to do is to give it a high range in case the load has been supplied in a higher way. However, you should know that when you want to provide a reinforcement to a column, it has to be in even number. It can't be in odd number. So it has provided 6y16. If 6y16 is not capable, the next it can provide is 8y16. It can provide 7y16, because that won't be reasonable. There will not be a proper way of arrangement of 7y16. Okay, so I'll definitely leave it like this. Then you just click on OK. Now you can see it has changed. You have 4y16 plus 2y16, and that is 6y16. Alright, now I have to make a conclusion to my review. When I opened the first one, which is 1C1, I realized that the arrangement of the steel bar is not in excess. It is accurate. It is not over designed, neither is it under designed. It is accurately designed. Then when I checked the other one, I realized that it is over designed to a reasonable level. But another thing you can realize here is that your second story, which is the story at the top, is having higher load, having higher moment, having higher area of steel required compared to the one you have at the bottom. So that is not reliable. So my conclusion is that the column design for ProtaStructure is not as accurate as it should be. Okay, alright, so if you enjoyed this video, kindly give it a like, and then if you haven't subscribed to my YouTube channel, make sure you give it a subscription. Thanks for watching.